So let's find a demand curve algebraically. We've got a consumer's preferences. Utility equals food times clothing. Price of food is PF and the price of clothing is PC. This consumer has income of I to spend, and food's on the horizontal axis. Let's derive this consumer's demand equation for food. The demand for food is going to be a function of the price of food and the consumer's income. And we're going to be looking for a specific functional form. The demand for food is also going to take into account the consumer's optimal choice of food. So we'll be looking for the optimal bundle. Well, we know how to find the optimal bundle. We can do it using the tangency condition. So the slope of the indifference curve equals the slope of the budget constraint. The slope of the indifference curve is the negative of the marginal rate of substitution, and the slope of the budget constraint is the negative of the price of food over the price of clothing. Well, our marginal rate of substitution is the ratio of the marginal utilities, so now I need to take my original utility function and find the marginal utilities. So my utility function is f times c. The marginal utility with respect to f is the partial derivative of utility with respect to f. We get c. The marginal utility with respect to clothing is f. Plugging back in, I get c over f equals pf over pc. I'm going to solve this for one of my variables, either c or f. In this case, it happens to be easier to solve for c. So this is one equation that I'll need in order to find my demand equation. The next thing I can go to is my budget line. So income equals the price of food times food plus the price of clothing times clothing. Now I've got two equations and two unknowns. I can simply substitute in. So my income equals the price of food times food plus the price of clothing times PF over PC times F. I can cancel out those PCs, combine some terms, and I equals 2PF times F. Solving for F, it's I divided by 2PF. This is my consumer's demand equation for food. And you can see that it is a function of income and the price of food. Now, if this consumer's income is $120 and the price of food is $10, we can easily figure out how much food this consumer will purchase. 120 divided by 2 times 10, or 6 units of food. Another thing we might ask ourselves, is food a normal good for this consumer? That is, when income increases, does this consumer buy more food? Well, here's my demand function. Food is a function of income and the price of food. If income increases, yes, my whole expression does increase, so food is a normal good. Another way of checking is to take the partial derivative of food with respect to income. And when I do that, I get 1 over 2PF, which is a positive number, which also confirms, yes, food is a normal good. Now, if instead the consumer's income were $200 and the price of food is $10, this consumer is going to purchase 200 over 2 times 10, or 10 units of food. So again, we're seeing that food is a normal good. As our income increases, the consumer buys more food.